Today I shall discuss about pile load test of two different type of soils formation, especially with reference to different Indian two popular codes. One is IRC 78, another is IS 2911. IRC is being used in our country for all river valley projects like bridge, barrage and other river valley projects. While IRC IS 2911 is very popularly used for other engineering projects like building, towers, or road bridges, except river crossings everywhere. Basically, there are few basic differences. For example, the effective pile length. IRC has considered 20 diameter and IS considered 15 diameter for frictional angle phi by 30 and 20 diameter for phi equal to or greater than 40. This variation leads to overburden pressures and finally it leads to change in total safe load. Another difference is the safety factor. IRC has recommended minimum 2.5 for compression load and for uplift load is 3.57. That is with a multiple factor of 0.7, 2.5 divided by 0.7, it is 3.57. Whereas in IS it is compression it is 2.5 and uplift it is 3. So that means IS is to some extent very conservative in, not very conservative, it is very liberal in uplift load. Here we are adopting same parameters. Diameter is 1 meter, total pile length below cut-off level is 28 meter. So as per IRC, this effective pile length for overburden pressure is 20 meter. So overburden pressure at pile tip is 20.94 ton per meter square. So for surface resistance, overburden pressure at midpoint of the pile shaft, it is 10.47 meter ton per meter square. Whereas in IS 2911, Total pile length is 28 meter below pile cap level. Effective pile length is 15 meter. Overburden pressure at pile tip is 15.7 meter. So overburden pressure for a skin resistance is 7.85 meter ton per meter square. Now you see, in IRC method, another basic difference is the main equation is ultimate pile load equal to ultimate tip resistance plus ultimate surface resistance, and which is derived from ultimate tip load is derived from C and C, PD and Q, half B gamma N gamma, and pile surface area. And RF is earth pressure tan phi and surface area plus reduction factor or adhesive forces, cohesion, and surface area. In another difference in IRC method is earth pressure coefficient K equal limiting to 1.8. In earlier in 2911 code, IS code 2911, it was limited to 2. Now this IS it is IS limited to 1.5. But what is the basic difference? You see, in IRC method, say it is 35, then it is coming out 1.8. Since it is entirely dependent on phi value, 1 plus this coefficient, earth pressure coefficient, equal to 1 plus sin phi divided by 1 minus sin phi with a soil concrete reaction factor of 0.5. So it is the earth pressure. It is limited to 1.8, whereas in IRC method it is 35 degree, then earth pressure coefficient will be unchanged, it will be 1.5. It will be 1.5, whereas in IRC method it is 1.8. In IRC method, you see, in IRC method our skin resistance is coming 1160 and tip resistance is coming 667 and total load is coming 1828, whereas in IS procedure it is 554, tip resistance is 554 and shaft resistance 725, and total is coming after all modification factor like group efficiency factor and self pile weight. It is coming distinct 462, and up here it is self weight is deducted, and in uplift self pile load is included. Now you see here it is 674 and uplift is 347 ton per pile. The difference you see 554 and 674, 267 and 347. It is 462 as per IRC method. The safe load is to 462, whereas it is in IS method is 674. This equation is this: QPA equal to QD by safety factor and efficiency minus into efficiency factor minus self weight. It is 674, and uplift is shaft resistance by safety factor multiplied by the efficiency factor plus self weight. Self weight is included because overturning force is required to pull out the self weight also. Besides the surface resistance, self weight to also be pulled out. The same equation is here, same equation also. The total load is coming almost 100 ton difference per pile. It is 674 it is 462, more than 100 ton. In case of uplift also it is 267, and here it is 347, about 100 ton. So 100 ton difference of a pile, that means it will be a great cost inactive. So IRC 78 is highly cost efficient in terms of loads, both compression load and uplift load. This is for granular soil. Let us discuss now about the cohesive soil. About the cohesive soil, you see here we are considering same soil parameters, same pile length and same soil parameters in both cases. This basic difference is IRC it is 15D. So overburden pressure it is 15.71, and it will be half of this. For skin resistance it will be half, because we are analyzing considering single layer stratum. There may not be a single layer, but we can convert to a single layer system in case of same type of soil. Here you see Here it is 20 dia, so our overburden is increasing, and we are adopting same soil parameters in both analysis, IRC and IS both analysis. Here it is in IRC 78, it is total load is coming 186 end bearing and uplift is 155. Here it is 133 is compression load and uplift is 149. Here is a difference too. But you see, in IS procedure, straight they have considered C50 soil, only C component is there. They neglected phi value. But IRC, they considered both C and phi. They using same equation for all type of soil. But IS, two different equation is there. For one is cohesive soil and another is granular soil. And they specially assumed, IS 2911 specifically assumed that when C is there, phi shall be 0. So they made it NC equal to C and C, that is end bearing component with area. This end bearing component is NC. NC means as a 9, bearing capacity factor as a 9. How it is derived? It is derived if phi equal to 0, then earth pressure coefficient will be 0. So there shall be no earth pressure coefficient except cohesive strength. So they considered it is as adhesive factor and cohesion. They are assuming the soil is phi 0 soil, so weight factor and surcharge factor shall be 0. Since sin 0 equal to 0, so next all portion will be 0. But practically it is not. Especially I am speaking about Northeast India. Last 52 years of my professional services, I never get any phi 0 soil in Northeast India and many places of the country, except some rich clay, Bihar, Gujarat, rich clay, where like that bentonite clay. In this type of clay, phi is expected to be 0. But in other cases, I am getting phi with both C phi soil. In this equation, if we change this phi, say it is 12 degree. In case of 12 degree, there will be no change at all. There is no change at all. 133, 149. While if I am changing the phi value in this equation, say 12, then what happens? The resulting resulting value is 207 and 166. Both compression load and uplift load both are increasing. That means they are giving proper consideration of phi also. So from these analysis, we can summarize that in phi 0 soil, in case of phi 0 soil, IS 29 is dependable, whereas in C5 soil, IRC 78 is more preferable. In original concept also, original concept, there was only skin resistance. Skin resistance means shear strength of soil. There was no reduction. Even in earlier days, during Tazagi's days, shear strength was calculated considering C plus N tan phi. Later on, other factors are included. HS, my opinion is, in spite of adopting IRC 78 for River Valley projects, we can accurately use IRC 78 for all engineering construction, whether it is bridge or building or any other structures, flyovers or any other structures. We can use IRC 78 very safely and very economically. Besides, this limiting value of 15D, effective pile length, this limiting value of IRC is 2 times dia irrespective of phi of any degree. But in IS 201, they have categorically considering 15D and 20D for very coarse grain sand where phi value is equal to or greater than 40. So in my opinion, while in previous, before modification in 2010, it was 20 diameter. In IS also, it was 20 diameter. So during latest modification, it reduced to 15 diameter. So instead of that, as recommended by IRC, it should be 20 diameter, since in earlier also I have been associated with deep foundation works for river valley projects, many bridges or many river crossings, high towers, microwave towers, transmission towers in river valley, river bed construction, and more than thousands number of projects I was associated, and thousands load test report I have been checked. We are always getting that the estimation of pile settlement for a group or a single pile, whatever it may be, pile groups are much less than the load test settlement is which are recorded at field after due correction of rebound, elastic rebound, we are getting much less than our anticipated, that is calculated settlement. Here it is 14.82. Another important factor is actually it is 17.02. It is 3 millimeter difference. Whereas in case of load test, we shall be getting 30 to 50% of this settlement. And I am considering this settlement, considering a group of 4 piles, 2 in row and 2 in column, strictly following IS 8009 part 2, that is 1:2, that 1:2 slope, this the angle of distribution of the stress. This is at 1/3, that is, we are considering it as a massive raft covering all 4 piles. In this raft, load will be distributed, load will be uniformly distributed, and load distributed below at an angle of 30 degree. That means it is 1 in 2 slope, 1 in 2 slope. So we have calculated accordingly, and we find in such there is little or no difference of settlement criteria, settlement, total anticipated settlement. But load is the safe load, both compression and vertical, both are varying. In case of horizontal load, there shall not be any difference. If we consider the depth of fixity, of pile, considering this subgrade reaction of the soil modulus in both equation, there will be nothing shall be different. It is more or less, it is approximately same values are coming. Now, what is the see, in case of cohesive soil, that is C5 soil, here it is coming 133 as per IS 2911, 186 as per 78. This basic difference is mainly because of 15 diameter and 20 diameter. Uplift is same, 149 and 155. In case of granular soil, you see, compression load 317 ton. Here it is 413 ton. It is 228 ton. It is 249 ton. It appears that it is hardly 20 ton difference, but for building or bridge, for 10 ton difference make a huge difference for us. Either we have to increase the numbers of piles to accommodate even 10% of loading, we may require 1 pile more. And there are other factors also. We have to use the same diameter of pile. We cannot use various dimension of pile. So I suggest to adopt IRC 78, which is very much reasonable, safe and cost efficient. 100-ton difference is not a matter of joke. Even 20-ton difference is not a matter of joke, because for this 20-ton load we may require another pile. So it may create another problem, because there shall be total load intensity shall be more, somewhere the total intensity shall be less. So in such cases, if we adopt IRC method, we can very reasonably and safely guide our client for safe and economic construction. This is also there. I hope my beloved friends and my beloved well-wishers shall surely agree with me with the opinion of adopting IRC 78 for pile loading analysis. Please have a nice day. Thank you all. Wish you very happy New Year, although it is too advanced. For any further information, please feel free to post me at your disposal. I am always available at jcgogoi@gmail.com. I am saying once again, jcgogoi@gmail.com. Thanks. Have a nice day, please.